All right, we are ready to kick this thing off. Our first talk today, and we also want to thank all the people watching on the live stream. So hello, live stream. Our first talk today is DevOps method for patching open source operating systems. So let's take it away.
All right, thanks. Can you hear me okay through this mic? Does that work? Hello? How about now? Better? Okay, all right. So good morning. I can't, okay, so we've said thank you like a million times, but honestly, can't thank you enough for actually having a venue like this. It's so cool to be in a room with other people, a lot of other people. So thanks a lot. Yeah, and I know also, I did want to mention the streaming folks, right? So this is being streamed, and we really appreciate the folks that are working on that. So I'm going to go ahead and get started with my talk. I want to talk a little bit about open source operating system patches. This is something that I kind of fell into, and I think if you're like me, like open source is open source, but how this whole stuff works, like it was really kind of, I had to tease it all out. So that's why I wanted to present this to you. Let me give you a little bit of background. I've been in security for a number of years. And you know, went through a number of different positions throughout different parts of the field, ended up as CISO at one of the companies downtown, and an opportunity presented itself for me to join the security team at Canonical. Now, Canonical is a company that produces Ubuntu. They had an opening to add security into the robotic operating system, ROS. So ROS is a complete open source ecosystem that you use for robotics, right? And they wanted to improve the security in there and so on and so on. So it was a really neat opportunity to work both creating and building the ROS security ecosystem while working with the very mature Canonical open source patching ecosystem. So that's kind of what I'm going to share with you, and that's the twist that you'll see behind it. We were putting together extended security maintenance for ROS, an open source product. So how you actually maintain the product after the open source community has moved on to the newer releases. And we'll talk more about kind of how that whole ecosystem works, right? So you'll notice, like we prepared this. I was working with folks on this presentation because I thought it was really cool. And then COVID happened, so I never got to give the presentation. And then I changed companies and things, you know, whatever. I still want to get this out there. So you notice none of my slides are really branded at all. They're very bland and so on, just because I didn't know what to do with them, right? So there you go. So now I'm with Plus Consulting, so hopefully I'll see you all around town. Yeah, so let's move on. What I plan to cover today, we'll talk a little bit about how vulnerabilities get triaged in the open source Ubuntu world. We'll talk about open source and how that happens and what upstream means and what downstream means and how code actually flows throughout this ecosystem to end up in my laptop, right? Versions and distributions become really important when we're talking about this, and also this concept of backporting a patch and backporting software. So if you haven't heard that, that'll be a new thing we'll cover, right? So please stop me as we go along. This is the first time I've given this presentation end to end, so I may not cover everything in enough detail, so if you get confused, just let me know, all right? So we're going to start with where the security team starts out at in Canonical, which is to patch Ubuntu, right? Ubuntu is just a collection of a lot of open source software. So where do we begin? And where we begin is at the CVEs, right? So we mine the CVEs to take a look at what's changed. There's probably about 150, usually less than 200 changes per week, right? So they go in and you get eyeballs on them to see if they apply. The interesting thing, if you didn't realize it, is that CVEs are all on GitHub. I thought that was pretty cool, right? So if you want to do this, you can go right ahead. You can go in and get your CVEs from 2021. You can watch any changes that anybody's updated. All the details are there, and they're in JSON format, so you can parse them out. You can have your own copy on your own laptop, all right? So we'll take a look at those. We'll pull down any of the changes and evaluate them to see if there's anything, first of all, that applies to the Ubuntu open source ecosystem, all right? And then if it does apply, then let's take a look at it and see how important it is, right? So you do an actual risk assessment. Has anybody here ever done decision making based off of CVSS scores for a CVE? Have you been successful? Yeah, it's kind of like, it's a place to start, but you know, CVSS scores have their challenges because everybody's different and so on and so on. So we do the same thing with Ubuntu, right? So you'll get a high ranked CVSS score on the CVE, you get to assess it and you realize, oh, well, when Ubuntu creates the code and they compile it, they use a compiler flag that compiles that vulnerability right out. So we're going to re-rank that as low, not high, because you're not vulnerable if you're using, you know, distributed software from Ubuntu, right? So all that kind of all fits together, and that's part of the daily routine on the security team. Pull in CVEs, look and see what's changed, use that to decide what the workload's going to be, what we're going to work on today, what's high risk, what needs to go out to our customers. All those results end up at this really cool website that's the Ubuntu CVE tracker, right? And this is our CVE reports. So we're going to, if you notice here, there's some of the most current work is listed here, some of the recent changes that are updates that have been, things that have been triaged. I want to spend a little bit of time, given that, you know, I got into this in robotics, we're going to look at a package called OpenCV, all right? And so it's just a package. We'll talk about what it is in just a second. But if you notice, there's 33 CVEs for OpenCV, okay? So 33 results, 33 CVEs, and it goes from 2019 down. And there's the priority ranking. So that's the manual triage. It comes back and says this is how important this CVE is to Ubuntu users. And then it's got all these columns about all kinds of different statuses, right? Things that are needed, things that are not vulnerable, things that have been deferred and all that. Like that gets confusing rather quickly, right? What do I need to do? And that's what I want to dig into, is where this chart comes from so that you can make this all manageable for you. So this looks really confusing, but to understand what it is, you really have to understand a little bit about how Ubuntu comes into being. And that's what I want to talk about. To understand that we're going to look into, we're going to look into what is going on with how Ubuntu is created. All right, so again, we're looking at the OpenCV package, and I'm going to take one of these vols and walk it all the way through from the open source patch that's in the public GitHub repo and bring it all the way back into an Ubuntu distribution. All right, so we're looking at OpenCV. Have you ever seen pictures like this? Right? They're really cool. You know, the little, like the rectangles that follow around eyeballs and, you know, recognize things in your pictures. That's what OpenCV does. Open Computer Vision Library. So this is a library of software. It's not really an application on its own. It's an open source library that gets included into other things. So it is included in a number of different products. If you're going to put out a product that has to do with some sort of image recognition, you're going to pull down a copy of this open source library and embed it in your product. Right? So obviously in robotics, we had a copy of it embedded, and that's why I care about OpenCV. All right? So here's all the CVEs that are related to this. Side note, the reason why there's so many CVEs related to the OpenCV project is because they are very active and very good participants and securing their software and tracking them by CVEs. It's not a recognition of the quality of the software. Sometimes you think a lot of CVEs means that it's bad software. Not the case. These guys are really good at tracking CVEs against their software. All right. So again, we're going to dig into this one CVE in particular, CVE 2019-15-939. Let's take a look at that. Where's my handle? There we go. So this is a CVE entry from the MVD, right? Pretty straightforward. There's an issue in a divide by zero, all right? And this is the CVE entry that's originally in, GitHub that you can pull down through JSON and whatnot. All right. The nice thing is here, this one actually has references. If you could see them down here, all right, it references the issue on GitHub that first identified this vulnerability, and then it even has a code fix. So let's take a look at that. All right, so this is the issue. And again, this is a standard GitHub issue, and this is the way the OpenCV ecosystem works. You have a bug, you file an issue, the issue gets triaged, and then it gets worked on and fixed, right? This one, if I'm not mistaken, I believe this was a result of a pen test vendor. It might have even been X-Force or something along those lines, where they were doing a pen test, they recognized this divide by zero error, and they filed this report. They filed this issue, and then they walked away, right? They're not the code maintainers. They just identified a vulnerability. Nice thing is, in this particular one, they gave us a lot of nice information about it, okay? So here's a system that's vulnerable, the version that's vulnerable. Here's some debug information. And then the one other thing that you'll see is invaluable is that they also included the vulnerability, the exploit. All right? Now, this isn't an exploit that gives you a root shell or anything like that. It's just an exploit to say, here's the problem, here's a file that you can use to run against this piece of code to reproduce my problem. All right? And as you'll see throughout the whole process, that becomes really handy, right? All right, so any questions about that? Right, so now we've got a vulnerability that was identified by someone, and another thing that goes along with that is the actual fix that was used to close this issue. So the fix itself is also in GitHub. GitHub remembers everything forever, right? So you'll see this is the fix. It's been merged into production. This is actually a little bit old. It's from 2019. So it was merged into production. And also, if you see, it was merged into this tag, right, version 3.4, right, in August. And the other thing is, so we actually get to see the code that was changed. Looks like the internet's not running too fast. All right. So here we see the code that was changed, all right? So it's in this file, right, hog.cpp, all right? And it's pretty straightforward, right? Okay, let's check and assert to make sure that this variable is not 0, check to see if this is empty, check to see if this is empty. All right, really straightforward stuff, just checking for zeros, all right? So easy fix, everything's good, right? So where are we now? We've got a vulnerability that was identified through a CVE. We've got an issue that was logged against the code, and it's been patched. So therefore, we're done, right? So unfortunately, no, this is only just the beginning. All right? To answer the question on whether or not you're patched, you've got to understand a little bit more about how Ubuntu gets created. All right? So let's talk about that for a second. All right? An Ubuntu release is a collection of software that works very well together, right? So I take all these different packages of all different versions that are all being, churned and created all the time, but I take specific releases of them and put them all together. I test them very heavily, and then make sure that everything's nice and stable, and that becomes a release. All right, Ubuntu issues a release every 6 months. They issue a stable release once every 2 years. So the interim releases are interim for testing to get to that eventually stable release once every 2 years, all right? This release cycle, all right, comes from their upstream. So the initial load of software comes from their upstream, which is Debian, all right? So Ubuntu is derived from Debian, and it gets added into the Ubuntu CI platform, which is Launchpad. So Launchpad does all the CI work for you. It builds the source code, runs the automated tests, bundles the binaries up into packages, and gets everything ready for the distribution. You test the packages out, make sure that they all work together, and then that becomes a release, all right? Once we have a release and we push out, particularly a long-term LTS stable release, we don't want to change it, right? So we don't want to bring in any new code unless we absolutely have to. So version updates, feature creep, all that kind of stuff, we don't add that to the old software because we want to keep it stable. So if you're running Ubuntu 18.04, you're going to stay on 18.04. You're not going to get the updates to OpenCV. If they come out, you're going to stay with the version that was released. All right, so in order to patch Ubuntu, we've got to patch the version that was released with that version of Ubuntu. All right, that's a little bit confusing, so let's take a closer look. So, are you familiar with upstream versus downstream? Have you dealt with that in the open source world, right? So, upstream produces the source code, downstream consumes the code from upstream, right? We're all talking about source, so this is all open source, right? OpenCV, as we saw on GitHub, maintains the code base, all right? So if you're going to program in OpenCV, you're going to program through GitHub, you're going to commit to that GitHub repository. How does that make its way to Ubuntu? Ubuntu is the downstream, and it consumes the software from OpenCV. Ubuntu has other downstreams. There are a number of versions of Ubuntu that are subversions, if you will, that are derived from Ubuntu proper. And Ubuntu itself is derived from an upstream. As I mentioned, Ubuntu is derived from Debian, all right? So OpenCV actually pushes its software to Debian, and then Debian, it's actually the unstable branch, gets copied into Ubuntu as we start a release. So Ubuntu is a derivative of Debian, all right? I don't know if you've ever seen this tree. This is Wikipedia. So it's got to be right? There's a really cool timeline here that talks about, it's a timeline plus a list of the derivatives of different variants of Ubuntu. And it's amazing if you look at the whole tree of who comes from what, right? This is all the open source upstream, downstream tree for Linux. All right, if you notice, we're talking about Ubuntu, and we talk a lot about Debian and Debian packages. If you look at the genealogy of Red Hat, it is not the same, right? Red Hat doesn't have an upstream. It is its own upstream. It is, the root source there. So it has a different packaging system and a different way of taking in the updates. So we're going to talk about how Ubuntu happens. A lot of you probably use Kali Linux. Do you know who Kali's upstream is? Debian, right? Yeah, so we'll find Kali on this chart, and its upstream is Debian, and so Kali will get updates from Debian. Right? All right, so now OpenCV is a very active project, right? So they're constantly updating code and taking in updates. There's a lot that's going on in the computer vision world. A lot of it is very academic. So if you're doing a thesis and you find a new way to recognize a new thing in images, you're going to probably commit that code into the OpenCV open source ecosystem. And from time to time, OpenCV is going to stamp code at a certain version and tag it and call it a version, all right? And that's standard software engineering practices, right? Version 3.2, 3.4, 4, 5, you know, so on, right? So it's constantly churning different versions of OpenCV software. Every once in a while, Debian pulls down the updated code from OpenCV. So they'll pull down that, just simply pull from the Git repo, right, through GitHub, and bring that into the Debian source tree, all right? This actually goes into Debian Unstable, which is also known as SID. So I feel unstable from time to time, whatever. But so this gets pulled in from time to time by the Debian project, all right, and gets pulled into Unstable, and then Unstable gets promoted into testing and then becomes a Debian release, all right? Ubuntu follows a very standard cadence. As I mentioned, every 6 months they start a new release cycle, and the release cycle begins by pulling that whole bundle of software that exists in Debian. All right, in Debian Unstable. So use that to populate, then we add in some more stuff that makes Ubuntu Ubuntu, you know, some different desktop, different features and whatnot, and then compile that all together and then start the testing for an Ubuntu release that's all that software working together. All right, what that means is that the version of OpenCV that gets pulled into Ubuntu mirrors what was in Debian at the time, and it changes. It's not every release of OpenCV, and if you want the latest features of OpenCV, you're not going to get them. Every time that you install Ubuntu 18.04, you're going to get version 3.2.0 of OpenCV. If you want something more recent, then you have to do something different, and you have to install it in a different way. But also understand, if you're going to upgrade your Ubuntu 18.04 to version 4 of OpenCV, then how are all your dependencies going to work? How well is that going to work together with the whole ecosystem? That's when you find yourself in dependency hell, if you've ever been there, right? So this all works together as long as you can stay with the features, and the features are what you're looking for. Quite frankly, if you want to use the latest version, then update your operating system. You know, go to the latest stable release, and things usually work pretty well. And usually OpenCV keeps an eye on what's going on with the Debian and the Ubuntu universe to keep things working fairly well that way. All right? So that's how we get a specific version of software into an Ubuntu distribution. That's how it gets picked. Any questions on that? Does that make sense? Or am I getting blank stares? We're good? Okay. All right, so another interesting facet of this is that you've heard about building from source. You know, you can download the tarball and make it and make install it, right? Or do whatever from source, right? If you install from source, you are going to get the latest version, right? And so if you want to keep track and you're doing in active development, that's probably what you want to do, right? But if you want the stable release that you get through using the APT toolkits and the standard updates and everything that's built into Ubuntu proper, you're going to get this version. If you're running version 20.04, you're going to get version 4.2.0 of OpenCV, okay? This has an interesting takeaway. All right, so we'll take a side note here. Based on what we've talked about so far, is that we're talking about, in this talk, about how you update Ubuntu packages. All right, how you get those automatic updates. When you have automatic updates enabled and software's coming down, you're automatically installing the updates, everything's good, everything's working together. But that may not work because you need the latest releases of the software, right? So if you're not using the Ubuntu standard distributions and updates, if you're building from source, then you're not going to get the updates that we're talking about. We're not going to get the patches that I'm talking about, right? If you want an update from source, then you have to download the updated source and rebuild it, right? So if you're installing from source, recognize that if you want to update you're installing from source or you're building from source, you've got to do it yourself. all right? So if there's a security patch or anything like that, you've got to do that. Hopefully you already knew that. You already knew that if you're going to build from source, that you've got to maintain it yourself, and that's a manual type of thing. However, this gets really challenging in an open source ecosystem if your application providers, if the people that bundle in this software don't pay close attention to that, right? So we mentioned OpenCV is a bundle of libraries that are all pulled together into just a standard set of utility libraries. Maybe there's an application that pulls down that code and then bundles that code and releases it, right? So that application then is going to have to get updated from time to time. And usually they do, right? So there's an update from OpenCV. The application pulls in the update and then bundles it up and ships it out the door, and you've got an updated application. That's good. Sometimes your vendors will pull down the open source, and they'll vendor the open source, create their own custom features. So they'll modify the source of OpenCV, right? Because they own the source. So they'll add some features in, add some checks right into there. They won't commit them back to the upstream, to the original open source OpenCV tree, right? And if they don't get committed, that means they can't take in the updates because it'll wipe out any of the customizations they've changed. So a lot of this gets really icky really quickly if you're not paying close attention to what's going on, right? So if you're in the open source world, hopefully you got that. If you're not in the open source world, hopefully you don't have to deal with it, right? So. All right, so let's go back to this CVE tracker website, right? So let's see where we're at right now. So we figured out that these rows represent individual vulnerabilities. We knew that, right? Then these columns represent the distributions, but also implied in that is which version of OpenCV we're talking about, okay? So we looked at 16, 18, and 2004. These all have different versions of OpenCV. All right, if you do an APT upgrade, right, you're going to upgrade that version of OpenCV, and that's what all this means is that this one's not vulnerable, and this needs an update, and this one's not vulnerable. All right, triage, the triage process that happened by the security team said, hey, we recognize we actually do need to update the source code here, right? So that's how to kind of understand what the CVE tracker is and what it means to you, all right? So just to summarize again where we've come from, Ubuntu is an entire ecosystem of software at a specific snapshot in time. The software is continually evolving, but an Ubuntu release takes it at a snapshot in time, makes sure it all works together, and you get a stable release. And you want a stable release. You don't want any updates that are going to break your stability of your system, right? All right, so to maximize that stability, they're only going to accept tiny updates, small updates. There's a stable release update process that's documented. The only time we're going to update is if we got to fix a security flaw or we have a significant bug that impacts software doesn't make it work. All right, so normally we're not going to see feature updates. Shouldn't see that. And also we want to update the software that was distributed at the time that release was made. Right? We're not going to update the software as it currently exists. We've got to go back in time to do that. That means that the software version that you're running rarely changes. As long as you stick with the operating system, you're running Ubuntu 18.04, it's going to be supported for 5 years. You stick with 18.04 and you're good. It's not going to be updated. You're not going to get new features. You're going to be stable. All right? So if we want to fix this vulnerability now, we have to patch multiple versions of OpenCV, and that's where we're at. We got the source code. The source code worked for version 3.4, and that's not what we're running, all right? So again, when we looked at the commit in GitHub to the open source tree, it was to OpenCV, got published in OpenCV version 3.4, all right? This is the date, again, we're working on 2019. And let me ask you an interesting side question, right? Anybody here know what a hog detector is? Yeah, so like if you're working this, do you have to figure out what that is? All right, you have to understand the software. How much do you have to figure out the software in order to figure out how to bring this patch in? Because it's not now, I'm working for Canonical, working for Ubuntu, not working for OpenCV, so I don't have all the context of what all this software does. So how much do I have to actually figure it out in order to do that? It's actually pretty cool. A hog detector is part of that smart logic that somebody did with a PhD and a couple other PhDs refined on how they figure out gradients and images and all this. So really cool stuff, and you can see it's actually being used a lot. All right, so that's why we want to fix this vulnerability or want to take a look at it, right? All right, so we took a look at the file, the source code that we got, and we saw that for Ubuntu 18.04, I am running version 3.2. All right, this patch went into version 3.4, so this patch does not exist in version 3.2. All right, so when I compare it, I could see, and we'll take a look in a second at the source code, I can see that the version that I have in Ubuntu 18.04 does not have this fix. All right, yeah, so that's, you got to have some C++ food to figure that out. If we look at a version at Ubuntu 16.04, right, that's version 2.4.9, based on at least what the triage said, that's not vulnerable, and 20.04 is running version 4.2, which should carry the fix all the way forward, so that shouldn't be vulnerable either. Right, let's look at what this vulnerability actually is, right? So if you're into C++, C code, right, you'll get this, but it's pretty straightforward, right? So we see over here, this is version 3.4, which is the patch version. It has this assertion up here, which is not in version 3.2. It has an assertion over here. It's not in version 3.2, and some assertions over here that are not in 3.2. We've got the source code. We saw that a long time ago. All I have to do is bring that source code back into version 3.2, and then issue that update into my Ubuntu update channels, and I'm good to go, right? And I'm patched. Pretty straightforward stuff, right? That process of taking something from version 3.4 and bringing it in backwards into 3.2 is what's known as backporting. And so if you haven't heard that term before, you're going to be backporting a patch, right? And normally your upstream only keeps the most current versions updated, maybe a few versions recent, but usually not as long as the 5 to 10 year operating system lifetime. So that's why you got to backport the patches. All right. If we take a look at version 2.4.9, this is 3.2 over here on the left side, and 2.4.9 is on the right. The code's not there. The code that causes the problem, which is these, I believe it was these two functions right here. Those functions don't exist in the older code, so the older code's not vulnerable. We've done our triage. We know that we don't have to make any updates to the 16.04, Ubuntu 16.04 or version 2.4.9 of OpenCV. All right? And if I look at version 4.2, just for the sake of completeness, I can see all my assertions are copied over into version 4.2, right? So the assertions here are there, and here they're there. All right, so we're good. We only have to patch that one version, all right? So that's going back to that Ubuntu CVE tracker. You saw that 16.04 is not vulnerable, 20.04 and beyond is not vulnerable, only 18.04 is vulnerable. That's the only patch that we have to backport, okay? So again, looking at it a little bit graphically, we see the same thing here. We're going to take some code changes that were here in 3.4.0 back to version 3.2. That's in Bionic, right? Ubuntu Bionic 18.04. All right, so in order to do this again, I stress that again, minimal changes, minimal impact to the end user. We want to use the original code that was published, and being open source, that's all available to you. So if you want to start working on patching stuff, you can do that. This is the OpenCV package in Ubuntu that is on Launchpad. So Launchpad is the CI/CD platform for Ubuntu. All right, so the package sits here. All right, if you notice, these are all the different libraries that get published with that package. There's a lot of them. here. And then these are all the different versions that are distributed with different releases of Ubuntu. So this is a whole pack of genealogy here. And you can see going all the way back to Trusty, Xenial, Bionic, Focal, Hirsute. So these are all the different versions that were released with Ubuntu. So if I want to actually get the original source code for the original OpenCV that was pulled from Debian, that was pulled from OpenCV, that was used to create the original 1804 version of Ubuntu, here it is, right here, right? We're going to take a look at the current version here. All right, so the current version for 1804, if you do, an AP install or whatever, and you get the source code or you get the binaries, it's from this source package. Right? Here's the changelog on it. So this is kind of neat. Eduardo was busy. Eduardo typically maintains this OpenCV from the Ubuntu side. All right, and you can see he actually updated all these CVEs as pushing out one update. So normally what happens is the mediums, you get to them when you get to them, but the highs, you get to all of them. And then when you have a high-risk vulnerability for a package like OpenCV, then you pull in as many of the mediums as you can. You got the patient open, let's pull in all these updates. So there's probably a high-risk update in here somewhere along the way that caused Eduardo to start working on OpenCV, pulled in, took a look at all the CVs that he could patch at a time, and put them all into this incremental release, right? So that was released in September 2018. Our vol's from 2019, which is why it's not included in here. All right? But you can also pull down this specific tarball if you want and open it up and take a look at the source and modify the source. All right? And so that's what you do when you're patching it. You go back and you backport that patch. So we have the 3.4, which is not in the Ubuntu ecosystem. We bring those updates into the 3.2 version, add them in, and that's how I patch in my source code. All right? So again, going back to the source code, it's pretty straightforward. I know I have to add this, so I just forklift that over into the 3.2 code, add this over, use a little bit of smarts to make sure, yeah, it does do what the vulnerability, it's fixing the vulnerability. Take a look at it, it looks good, all right? Make minimal changes, don't change white space, don't add extra stuff, just put it over there, and I should be good, right? So I go ahead and compile it, and it fails to compile. All right? So my backport failed. Why did it fail? Because in version 3.3, they added an empty method to the size object. All right? So now I've got a problem, right? So my backport, my fix, is relying on something that was added in version 3.3 and used in version 3.4. So if I'm fixing version 3.2, I can't use the same fix. Right? And I've got to write some code. So it's not as simple as just lifting the code. You actually have to write it and change it. So this is where backporting becomes kind of challenging, right? This is pretty simple because we're just backporting something that's not too different, right? It's only probably about 6 to 8 months worth of development time difference. But imagine if you're backporting something that's 4 years old, 6 years old. It ends up getting to be kind of challenging, right? So I talked with Seth. Seth is one of the guys that works on this team. He's been doing this for quite a while. And we were talking about backporting, and he dropped me a note, and he said, he gave me this bulleted list of problems that he runs into from time to time when he's backporting patches, all right? So again, imagine that we've got a patch over here from a new version, and we want to bring that back to an old version because there's a vulnerability in the new version that's carried back to the old. Sometimes all you got to do is clean up white space, move it over, and you're good to go. All right? Sometimes the code has moved. All right? So it moved from one source file to another source file. So you got to track down where the code is, and you got to start reverse engineering what this piece of software does. Right? Sometimes all the variables got renamed. So I forklift my code, but it's working on variables that don't exist in the older version, and you got to tease all that out. All right? Sometimes, as we saw here, the patch depends on macros or functions or methods that don't exist in the older code, so you have to rewrite things. You can't just forklift that method back over, because then it's not going to be compatible, right? And that goes to another point, which is on my next slide, but it has to remain, the binaries have to remain compatible. So if you do any reverse engineering, you probably know that you enter into a function with a structure, it's a specific structure, right? If your patch is going to change that structure of how you call a function, it's not going to be compatible. Everybody that depends on that header has to recompile that piece of code. It gets to be a nightmare. So you usually don't make anything that's not compatible in that way, right? Sometimes the code was completely rewritten, and then you have to figure out whether the vol exists in the old code or not, and then it gets into some more reverse engineering the code and so on. And also, when you're looking at a vol, how many times have we looked at it and we say, oh yeah, they patched the vol, but there's more to it than that, and you have to patch and patch again. So that whole idea of the vol being the tip of the iceberg becomes one of the problems as well. All right? So let's assume that we got over all that, we've patched all our code, now we've got to test it before we push it out, right? So you begin by testing it locally, and you're testing it against the original unpatched. You take the vol, the exploit, right? So we got an exploit with this piece of code. So you take the exploit, and you run the exploit against the code, that the original code, first of all, to see that, oh yeah, it fails, and now I know how it fails, and that's what I got to fix. And then you run the exploit against the patch code to make sure it's not exploitable. If you don't have an exploit, then you probably have to create one in order to really test to make sure that you've patched that vulnerability. All right? And then you run all the other tests, unit tests and so on. The OpenCV library is huge. Their tests take hours to run, and there's thousands upon thousands of tests, unit tests that happen in there, right? And then you have to test all the different versions, right? So if I put the patch out for Ubuntu 18.04 plus 20.04 plus 16.04, I've got to test all those different versions. And then, well, if it's Python, right, then you got to test against Python 2 and Python 3, because we're talking about older systems that support Python 2, right? And then you have to test it against different architectures, right? So you want to test ARM, i386, and so on and so on. So you got to do all that testing. And then for OpenCV often ties into hardware. So you really want to do some kind of hardware testing. So can you emulate the hardware testing and so on and so on. And then you want to kind of test patch delivery. So you want to put it into a mocked up patch delivery system and then make sure it gets delivered and gets updated and so on and so on and so on. Testing's hard, right? Backporting to older versions gets really challenging really quickly, right? So when you're backporting to older versions, you really have to step back in time to the way the world was in 2018 and then test the patch in 2018. That means all the stuff that you use to test, right? Anything that's in your CI/CD pipeline for testing has to be the 2018 version. Because imagine if you're testing your 2018 code against signatures from 2021 against a new vulnerability or new code pattern, problematic code pattern, and you find it in your old code, or you can update your old code, right? So really messy stuff. That's why it's hard to maintain older operating systems and older software, right? It just gets really challenging. Backporting patches is hard. Hats off to the guys at Canonical that do this day in and day out. I don't know how they can keep in their head all these different software packages, all the thousands of packages that make up Ubuntu, rip out the high-risk vulnerabilities and rip them apart and patch them for all those different distributions. They do extended support as well, so they're patching all the way back to Ubuntu that's 10 years old, right? And have to recreate the environment as it was 10 years ago and patch that. So it gets exponentially more complex. And this is why we put software into extended support. This is why sometimes you have to pay for extended support, because there's just a lot of work to make sure this works. So hats off again to the security team at Canonical that makes all this happen. This is their Launchpad group, right? The manager over there is Sean Murphy. Sean took over from, if any of you know Joe McManus, he used to be here at SCI. He used to manage this team. And also, got a lot of help from these guys in putting this presentation together. Steve Beatty manages the kind of the day-to-day work on how this all happens. All right, so some really, really cool stuff that happens there. All right, so one last thing I want to leave you with. We've talked about Ubuntu and how this works, and that's hopefully informational for you to understand how this works. As long as you do your automatic updates, you're good. This is the stuff that you're getting. They're prioritizing. I feel comfortable they're prioritizing things right. All right, but if your software looks like this and you're not getting your software through a standard APT update, it might be time to ask how they do their updates. How do they get their code from upstream? How do they consume it? Have they forked the code? Are they maintaining their own branches? If so, are they backporting the patches? This is the kind of stuff that we were working on doing for the robotic operating system to maintain that after the upstream stopped maintaining it. This is something that is, you have to be very aware of in the open source ecosystem. So I'm going to leave it there and see, do we have any questions? Anybody have any thoughts? Yeah.
So when you're backporting code from these upstream projects and you cherry pick commits in and you have completion and stuff, how does Mongo manage the confusion that causes version numbers being installed being different, vulnerable or not vulnerable to the upstream projects version numbers? And I think part of that problem is technical, and I think part of that problem is non-technical. So it's just is there marketing and awareness that the versions are slightly different between the same numbers?
Yeah, so that's a great question. So how do we get the version numbers right? And why does that matter? It's because when you do an APT update and then an APT upgrade and look and see what software you're going to get down, it's all based on the version number, right? So the version number has to be bumped up for you to get the new software installed, right? So if you're running version 4.2 and you have an update 3.2.1, that's not going to be installed because it's an older version, right? But if you're running 3.2.1 and you see a 3.2.2, you're going to install that, right? So there is a standard, and I think it's documented in their public wiki about how they actually number these. And if you'll see this, these are numbered 3.2.0. .dfsg and so on. That versioning and the way that they number the releases makes sure that you are getting the updated code if you have the older code installed. So if you have version 3.2.0, we will update it 3.2.0.1, right? So the way the version numbers happen, make sure that you get the right code. So if you do the APT info, I think, the APT info is going to give you the whole, I forget exactly the command because I'm stuck in Windows now with my new job, but within one of the APT tool sets, it'll give you the full description of what is installed and what is available. And actually that comes from information that is distributed in this package. Like it's actually just a text file that comes with it. So they should be built into the overlay that Debian puts on top of the code when they package it, right? And then the Red Hat is going to have a different overlay. But yeah, absolutely. So versioning is, there's a lot of nuances to versioning, and versioning is challenging, but it's also algorithmic. So very standard, you can make sure that you get the right one. There's also the issue of, this is an open source world. Shouldn't they commit the patch back to upstream? So if I patch version 3.2, shouldn't I give that back to the OpenCV community? And that is an option for some packages, although the community has to be still supporting 3.2, you know? If the community is not supporting 3.2, they're not going to take updates to version 3.2 anymore. Right? So any other questions? All right, so thanks a lot for attending. Thanks a lot for being here. I really appreciate it. We got one more. I'm sorry, could you say again? Yeah. Yeah, so if you, under Ubuntu Advantage, you're going to get the support, you're going to pull in the updates. The LTS versions supported for 5 years. Under Ubuntu Advantage, you get the 10-year support so that you can run your operating system for 10 years. And again, in the robotics world, that was why that was so important to us. It's because your hardware is going to last for 10 years for sure, so you want to make sure your software will run that long as well. All right? So if you got any more questions, stop by and see me. I'll probably be at the Plus booth. And if you stop by, we have this wearable Wireshark self-decoding packet capture. So stop by and grab a t-shirt. And I'd love to chat more about this. So that's all I got. Back to you. Thank you.
Thank you very much, Sid. Great talk.